Precession is a change in the orientation of the rotational axis of a rotating body. In an appropriate reference frame, it can be defined as a change in the first Euler angle, whereas the third Euler angle defines the rotation itself. In other words, if the axis of rotation of a body is itself rotating about a second axis, the body is said to be precessing about the second axis. A motion in which the second Euler angle changes is called nutation. In physics, there are two types of precession, torque-free and torque-induced. In astronomy, precession refers to any of several slow changes in an astronomical body's rotational or orbital parameters, and especially to Earth's precession of the equinoxes. Astronomy. In astronomy, precession refers to any of several gravity-induced, slow and continuous changes in an astronomical body's rotational axis or orbital path. Precession of the equinoxes. Perihelion precession, changes in the tilt of Earth's axis to its orbit, and the eccentricity of its orbit over tens of thousands of years are all important parts of the astronomical theory of ice ages. Axial precession. Axial precession is the movement of the rotational axis of an astronomical body, whereby the axis slowly traces out a cone. In the case of Earth, this type of precession is also known as the precession of the equinoxes, lunisolar precession, or precession of the equator. Earth goes through one such complete precessional cycle in a period of approximately 26,000 years, or 1 degree every 72 years, during which the positions of stars will slowly change in both equatorial coordinates and ecliptic longitude. Over this cycle, Earth's north axial pole moves from where it is now, within 1 degree of Polaris, in a circle around the ecliptic pole, with an angular radius of about 23.5 degrees. Hipparchus is claimed to be the earliest known astronomer to recognize and assess the precession of the equinoxes at about 1 degree per century. Caltech Swedlow disputes Hipparchus's knowledge of precession because Hipparchus apparently did not necessarily indicate anything like a motion of the entire sphere of the fixed stars with respect to the equinoxes. The precession of Earth's axis was later explained by Newtonian physics. Being an oblate spheroid, Earth has a non-spherical shape, bulging outward at the equator. The gravitational tidal forces of the Moon and Sun apply torque to the equator, attempting to pull the equatorial bulge into the plane of the ecliptic, but instead causing it to precess. The torque exerted by the planets, particularly Jupiter, also plays a role. Perihelion precession. The orbits of planets around the Sun do not really follow an identical ellipse each time, but actually trace out a flower petal shape because the major axis of each planet's elliptical orbit also precesses within its orbital plane, partly in response to perturbations in the form of the changing gravitational forces exerted by other planets. This is called perihelion precession or apsidal precession. In the adjunct image, the Earth apsidal precession is illustrated. As the Earth travels around the Sun, its elliptical orbit rotates gradually over time. The eccentricity of its ellipse and the precession rate of its orbit are exaggerated for visualization. Most orbits in the Solar System have a much smaller eccentricity and precess at a much slower rate, making them nearly circular and stationary. Discrepancies between the observed perihelion precession rate of the planet Mercury and that predicted by classical mechanics were prominent among the forms of experimental evidence leading to the acceptance of Einstein's theory of relativity, which accurately predicted the anomalous. Deviating from Newton's law, Einstein's theory of gravitation predicts an extra term of AR4, which accurately gives the observed excess turning rate of 43 inches every 100 years. The gravitational force between the Sun and Moon induces the precession in Earth's orbit, which is the major cause of the climate about oscillation of Earth that has a period of 19,000 to 23,000 years, it follows that changes in Earth's orbital parameters is important to the study of Earth's climate, in particular to the study of past ice ages.